Okay, so first we want to use the graph of the rational function to identify the domain of the function. So to find the domain, it will include all the real numbers except for where there are vertical asymptotes. So the vertical asymptotes are right here. So the domain is going to be negative infinity, comma 2, then the u, and negative 2 to 2. Okay, then the next thing we're going to do is the range of the function. So to find the range, it will be the horizontal dashed lines, which are at 1, and it approaches all the other values, but it only marks on 1. So for the range, it will be negative infinity, comma 1, with the u, then a 1, comma infinity. Okay, so the next thing we want to do is find the inserps of the function, if there is any. So it's where the graph crosses the x-axis. So we could see that happens at negative 1 and 1. So the x-inserps will be x equals negative 1 and x equals 1. And the y-inserps is where the graph crosses the y-axis. So that would be 0 and negative 1. And f of x equals negative 1 actually. Okay. So then for the asymptotes of the function, okay, so first for the intercepts, we want to just make it into this form. So for number 4, the asymptotes are where the graph becomes undefined. So that would be negative 2, and yeah, just 2. Okay. Negative 2 and 2. So it's just going to be x equals negative 2 and x equals 2. And the non-vertical are the horizontal ones, so that would be just 1 right here. X equals 1. Okay. Is f1 positive or negative? from the graph at x1, it's below the x-axis, so it will be negative. So F1 is negative. Okay, I'll just put n. The intervals of any over which the function is increasing, decreasing, or constant. So I would say that they're increasing on negative infinity to -2, because it's from -2 to infinity. Then they also are on to infinity. That's the increasing. Then for decreasing, from -2 to 0, they're decreasing. Yeah, from 0, okay. 0 on the y-axis. And then there is no constant because the graph isn't like flat. It's curved. So there is the first one. Let's upload the second. So we're going to be working on this second equation, which says graph the quadratic function, starting from the parent function, and then identify the coefficient, and yeah, so I don't know how we're supposed to graph it. Like make a graph? Okay, but the leading coefficient, so that would just be negative, 1/2. Okay, and the parabola would open downward. The axis of symmetry. Well, the formula uses x minus h. So in this case, it would be x minus 3. So the axis of symmetry would be -3. Next, we want to find the intercepts of the function, if there is any. Y-intercept. So for the x-intercept, we will set f of x to 0. Well, okay, so this wouldn't actually have an x-intercept because you have to square this number, and that can't be a negative, so there is no x-intercept. And then for the y-intercept, you want to set x to 0. And then we will do -1/2 with x at 0 plus 3 squared minus 4. So that is going to equal, let me go over here, -1/2 0 plus 3 is 3, squared would be 9, minus 4, which will then equal -9/2 minus 4, which will then give us 17/2. So our y-intercept would be 0, 17, -17/2. Which is actually just 8.5. Okay, so then next we want to do the domain of the function. So, do that over here. So yeah, the domain is just going to be -∞, infinity. And the range. And the range. Well, we know it's -∞, because it is defined all real values. And for the range, we said earlier the parabola opens downward, and -4 will be our maximum range. So it would be -infinity, because it's going down, and then -4. Okay, and then for the vertex, the vertex is going to be -3, -4 from our two numbers that we got. And it would be a maximum because it's opening downwards. And we can tell that because of the a equals 0. Or not a, when we made x equals 0. Okay, so next. Alright, use the properties of the logarithms to write the expression, simplify if possible. Assume all variables represent real positive numbers. So first we want to put it to the power of logarithm, which would be log. Well, I'm not going to write out the whole equation. I'll just write what it will turn into, which would be 2 times log 5 4x over z. Okay, and then next we want to use the quotient rule, so that would be 2 times parentheses log 5, and then we'll put that 4 times 7, x. In the parentheses as well, and then we'll do minus log 5 times z. Then we will keep solving. I'm going to do it up here. We're going to do log 4 times x equals log 5 times 4 plus log 5. Oh my gosh, my computer can't keep up. times x. So that is just how we rewrite the expression. I hope you can read that. And it says, yep, that is simplified, so there you go. That's how you solve all three of those problems. Thanks.